Okay, welcome back to the channel. Today's lecture is going to be Chapter 11, Airway Management. And so let's begin. Good thing about the video lecture, of course, is, if you feel competent in that certain area, you can just kind of skip along in the lecture. But I would recommend, at least, you know, making sure you're competent in that area before moving on, right? So let's introduce the chapter. So it's extremely important subject that gets overlooked quite a bit. It gets overlooked because sometimes we assume we have a patent airway when we shouldn't assume. There's been plenty of professionals in this in our job sec that's been burned on airway all the way up to the level of physician. um, they take it for granted, and it's important to never take an airway for granted. And so, if we don't know by now, we should know this by now. Being this is an advanced EMT course, all about perfusion, right? And we know that oxygen reaches the body cells, you know, because we inhale oxygen from the outside in. From the atmospheric air, the 21% oxygen, we inhale that in, right? Goes down the trachea, into the bronchioles, eventually making it down to the alveoli. And remember what we talked about at EMT school, that VQ ratio, right? So this would be the V with the oxygen in the standby mode inside the alveoli. And then the Q part would be that blood, right? The blood comes by, red blood cell, and through that process of diffusion that occurs where oxygen comes out of the alveoli into that red blood cell, and CO2 transfers from the red blood cell back into the alveoli. And so then once in the alveoli, of course, we're going to exhale that CO2 back out to the atmosphere. That's how we rid ourselves of that. All right. So let's move on. Let's look at the anatomy, right? We have to remember how the airway is divided. It's divided into the upper airway and into the lower airway, right? And so the larynx being that dividing point from the upper airway to the lower airway. We talked about a second ago about that exchange of air between the lungs and the environment. You're inhaling that, or you're breathing in that 21% oxygen, right? So that kind of meets uh, that definition of ventilation, right? The exchange of air between the lungs and the environment. We have the diaphragm, and we've talked about this. Diaphragm is responsible from, depending on what book you read, but over 70% of breathing is initiated by the diaphragm. And here we have an image of what we just got done talking about. All right, so here we have the nasopharynx. We have that nasal air passage. We have the pharynx. Remember what the pharynx is, right? It's just a fancy name for the throat. The oropharynx, which is part of the back of the throat, or sorry, part of the front part of that throat area, the mouth, the epiglottis. The epiglottis is that structure um, that helps protect food or a foreign airway, foreign body airway, anything to get into the trachea, that leaf shape structure, right? And the larynx is the dividing point. Okay, larynx is the dividing point. If we continue to go down, we will be in the trachea here. We see our lungs, the carina. The carina is the dividing point between the right and the left bronchioles. Right, here's our diaphragm, or it is very muscular, as you can see there. Here again, our alveoli, and you see the red and the blue. That is your capillary bed, and it literally almost sits right on top of the alveoli. And we've talked about this a while back, but that capillary bed gets pushed away from that alveoli. Well, it takes longer then for diffusion to occur. And let's go back, just checking my notes real quick. I didn't mention the nasopharynx really, but the nasopharynx, that part of your throat, because it's pharynx, right? And then naso. That's kind of where your sinuses drain if you have a sinus infection, something like that. I'm sure we've all experienced that. But that nasopharynx, its function really, it's a it's a mucosal membrane, meaning it stays wet in there. And it has that cilia, that those fine hairs inside your nose, and it's a filter, and it filters out dust, particles, that sort of thing, and it also helps to keep the temperature of the air that we breathe in, a little warmer. There's the things called turbinates, right? Turbinates that you'll find in your nasal passageway as well. And that helps do just what I said. It helps to filter, it helps to keep that air moist, and it helps to propel air down from the nasopharynx down into the trachea where it can be used by the lungs. I mentioned the sinuses a minute ago. Of course, there's sinus cavities there. And certain times, if you have a fracture, you can actually fracture those sinus bones. And mentioned the epiglottis. Mhm. So the larynx again, being right here, it's a cartilage type. It's made of cartilage. Um, that is where the thyroid's located, right? And that glottic opening, that's that opening just before you go into the trachea. The glottic opening's there, and that happens to be the most narrow portion of the adult airway. And a lot of times, if someone's choking, that's where you'll find your obstruction right there, just up around that glottic opening. And so then from the larynx down, we talked about the lower airway. We talked about how important it is, its function. And its function is what? It's gas exchange. That is the function of the lower airway. The function of the upper airway is to get that filter the air and propel that air down to the trachea. But once it gets to the lower airway, it's all about gas exchange. We need to get that oxygen, you know, down the trachea and into the bronchioles, into the bronchioli, and then down to that alveoli. The visceral pleural. Remember the visceral pleural? That's that membrane that actually lays right on top of the lung tissue itself. And then we had the parietal pleural, and um, that's actually just above it, and it attaches to the thoracic cavity or chest cavity, chest wall. We mentioned we talked it's just a review for you at this point, really. When we mentioned the alveoli and gas exchange, it's pretty common knowledge for you guys right now. And then we mentioned the phrenic nerve in the past, and we're just going to mention it again. The phrenic nerve is that nerve that innervates the diaphragm, right? The respiratory center of the brain up here sends that message to the diaphragm to contract. All right. And so this is there's the hyoid bone. We mentioned all of this a minute ago. All right. And so then we could kind of talk about the certain parts here. We mentioned the nasopharynx. I think we need to really go over that anymore. The larynx, we said there's that your thyroid glands here. We did talk about the function of that lower airway. Remember the bronchioles, the bronchi. Sorry, the bronchi, the bronchioles, the alveoli. Talked about the visceral pleural. Kind of going through this. We did not mention surfactant yet. And so surfactant helps to increase the surface area of the alveoli. And that's a good thing because the more surface area, the larger those alveoli can be. Think about surface area. So when you think about surface area, try to kind of bring it home for you. Think about the little grasshopper, right? That can act, or the tiny bugs that can actually walk on water, right? And they can actually just scoot along the top of the water. That's because they can do that, right? It's the science behind it, but it's that water presents a surface area for that tiny creature, and so um, that's kind of the same principle here. The larger the lake, the better the surface area. Well, the larger that surface area of the alveoli, the better for gas exchange. When we have inadequate surfactant, that's going to cause a problem, right? That's going to cause a problem because it's going to decrease that surface area of the alveoli, and it'll decrease alveoli ventilation, and that leads to atelectasis. It's going to lead to atelectasis, right? And so it all comes down to where the surface area is going to result in a smaller surface area, result in a less of the stretch of the alveoli. Here we have that phrenic nerve again. We're talking about it again. And the phrenic nerve again sends that impulse to the diaphragm to contract. And then we have the relationship of the cardiovascular system and how it works with the respiratory system. They have two different jobs, but very similar jobs because both participate in gas exchange, right? Both participate in the delivery of oxygen. And so that's kind of how you got to look at it. If we have a problem getting the blood to the alveoli to make gas exchange, um, then we have hypoxia, right? If we can't get the air to the alveoli to be there for the blood to arrive, then we have a problem with gas exchange. So it's that constant supply of oxygen that we so desperately need. And here's just an example of that. You can see where we have a little clock here, and so 0 to 1. And this is, I don't want you to think of this as like the cardiac arrest model. This could be somebody who's just severely hypoxic. 0 to 1 minute, we're going to have cardiac irritability. And we know why, in a way. I mean, we've talked about it in class a little bit, but we can take it back to when we're talking about aerobic and anaerobic metabolism, and we can talk about, having too much acid, right? We can talk about that. And so if that sodium potassium pump can't do its job, we're going to start seeing that cardiac irritability, or it could be the heart tissue itself that's becoming necrotic, and causing the tissue that sits right above the pacemaker and start causing that cardiac irritability as well. 0 to 4, we can look at brain damage. It says not likely. If we look at 4 to 6, we could say that brain damage is possible. And anything over 6 to 10 minutes, brain damage would be likely. More than 10, it's irreversible. And so that's why it's critical when we look at our response parameters. It's critical that we have somebody there within that first 4 to 5, 6 minutes that can provide this, that can reduce or stop cellular death, right? And so that's us. If we're at a fire station somewhere, we know the fire department can generally get there quicker because we are set up in a certain way to protect property, right? And we have to be near that property, um, to be there for the fire, because fire doubles every minute. And so that's kind of what we're looking at. We get somebody there quickly, and we know the EMS unit typically is not there within that 4 to 5 to 6 minute time range. Not, I mean, sometimes they are, but not always. And because of just the way the system's set up, the EMS units are set up to, are, s- are staged in certain areas where call volume is higher at a certain hour of the day, things like that. And so, um, but if we can just get there and open an airway, put an airway adjunct in, begin ventilations, we can, we can reduce the likelihood of any of this bad stuff happening. So let's talk about ventilation. What is ventilation? That's the first thing you need to ask, because it seems simple, but when we start talking about these definitions, they can get confusing. So ventilation is, just like I said earlier, it's the process of moving air into and out of the lungs, right? It's that process of moving air from the outside, 21% oxygen, down to the lungs. Okay, it's necessary that ventilation is necessary to have oxygenation and respiration. Remember that, because respiration is not ventilation. Respiration has its own definition that we'll get to in a minute. And so if someone's not breathing adequately, we have to intervene, meaning we have to recognize the patient's not breathing adequately, and we have to intervene, right, to stop, to fix that. Once we recognize it, we must immediately act to fix it. All right. So inhalation, all right, inhalation, it's different than ventilation, right? Let me maybe a slide actually here. All right, so inhalation is that active muscular part of breathing. It's when the diaphragm starts getting into the game. Okay. If If the diaphragm is not working correctly, then we won't have good ventilation, right? We won't have good ventilation. And so there's reasons that, for that. The phrenic nerve could be damaged, the diaphragm itself could be damaged. So there's things that can happen, right? That to cause that. And so inspiration is actually focused on delivering the oxygen to the alveoli. And we have to understand definitions of what tidal volume means, respiratory rate, and we have to understand how they both affect the minute volume. Again, when we're talking about inhalation, we get that maximum inspiration that occurs when the diaphragm and those intercostal muscles are contracted and those lungs fill with air. All right. And so the lungs, you know, they don't have truly any muscle tissue, right? They have the bronchioles and the bronchioles. Those are smooth muscle. They don't have any muscle of their own to do that. They totally are dependent upon the diaphragm. And remembering about the diaphragm is that muscle that's kind of unique because it's both voluntary and involuntary, right? Voluntary meaning if I want to take a deep breath right now, I can. I can actually do that and my diaphragm will contract. But if I don't breathe in a while, like I'm sleeping at night, I'm not concentrating on breathing, I'm concentrating on sleeping, right? Well, something has to tell that diaphragm to do that, and then becomes involuntary. So when we talk about partial pressure, what are we talking about? What are we talking about? So that's all partial pressure is just a measurement of gas, right? It's a measurement of gas. um, when we're talking about carbon dioxide, we're talking about a partial pressure, 35 to 45. All right. So that's just a number. But we read that as a partial pressure. We talk about that. All right, so I'm just about out of time at this point. I'm doing this morning before our class starts, and I have to get ready for that. So I will post this. It's about 25 minutes long. I will post this, and I will pick back up here in a little while. On the, we'll talk more about this ventilation process, and we need to talk about atmospheric pressure and that sort of thing. So we're gonna get a little deep, maybe. It's not new information. This whole chapter is it's when it comes to physiology of breathing, it's not new. All right. So, but we'll go over it, discuss it for you to review. And so I will see you on the next video.